Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing classification of carbohydrates. I have given introduction and discussed classification of carbohydrate. As for example, monosaccharides, disaccharides, oligosaccharides, polysaccharides, all things I have discussed. Also I have discussed preparation of glucose. Now I am going to discuss a structure of glucose. Glucose is very important compound, and so we should know its structure also. And now I am going to discuss a structure of glucose. Glucose is an aldohexose and is also known as dextrose. Glucose, two more name is there. Glucose is an aldohexose, first things, and is also known as dextrose. It is the monomer of many of the larger carbohydrates, namely starch, cellulose, etc. This glucose is a monomer of larger carbohydrates, as for example starch, cellulose. It is probably the most abundant organic compounds on the earth. Again, important point. It is a most abundant organic compound. Probably. It is probably the most abundant organic compounds on earth. It was assigned the structures. How we will give the structure? Then on what basis you will tell the structure? Then now I am telling the this evidence. Only on that evidence you can know the structure of glucose. What are the evidence? Then first, that is the first evidences I am telling you, it's a molecular formula. Okay, molecular formula. Its molecular formula was found to be C6H12O6. I told you that it is assigned the structure on the basis of the some evidences. Then first evidence, that is the molecular formula. Its molecular formula was found to be C6H12O6. Second, on prolonged heating with Hi, it forms a normal hexane, suggesting that all the 6 carbon atoms are linked in a straight chain. This is the second important point. On prolonged heating with Hi, hydrogen iodide, it forms a normal hexane. Hexane means 6 carbon. Normal hexane, suggesting that all the 6 carbon atoms are linked in a straight chain. Means glucose, you can write like this: CHO aldehyde group, after that CHOH in 4 number. Okay, CHOH, 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 CHOH. Okay, like that way 4 CHOH are attached, and one is CHO and last is CH2OH. Total 6 carbon. CHO, that is 1 carbon, and in the end CH2OH, 2 carbon, and in the middle CHOH in 4 number. Means CHOH, again CHOH, CHOH and CHOH. Then CHO, from that next carbon, from the next carbon, one side H is there, other side OH. Same way again, next carbon again H, with the carbon left side H, right side OH. Again third carbon same, fourth carbon same. Then we can write like this, CHOH whole 4. Then this CHOH whole 4 is attached with CHO, one side with CHO and other side with CH2OH. And this, when it will react with HI, and if you will heat it, then it will give normal hexane. Means glucose on heating with HI, it gives normal hexane. Means CH3, CH2, 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 CH3. In the beginning and end CH3. In the middle 4 CH2. CH2, 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 CH2. All CH2 are attached to each other. This is the normal hexane. Means glucose on heating with HI, it gives normal hexane. Okay. A structure you are studying. Then here you have studied that 6 carbons are there, 12 hydrogen is there and 6 oxygen is there. Okay, in glucose. And that's why here when you will eat with HI, it will give normal hexane. Now third, glucose reacts with hydroxyl amine, means NH2OH. Glucose reacts with hydroxyl amine to form an oxime and adds a molecule of hydrogen cyanide to give cyanohydrin. These reactions confirm the presence of carbonyl group, means CO group, in glucose. Okay, that in glucose CO group is there, carbonyl group. Then only by this reaction these things in this reaction it will be clear. From this reaction it will be confirmed that glucose has CO group, carbonyl group. Then reaction is again same way. Glucose always we can write CHO, and after that in the middle CHOH whole 4, and in the end CH2OH. Then CHO is attached with CHOH, and the end CH2OH. CH2OH, that is also attached with CHOH. Then this glucose, when it will react with NH2OH. NH2OH means oxime. Then where reaction will take place? Then near CHO. CHO. Then what will be the reaction? The reaction is easy. What will happen? NH2OH. Then this NH2OH, H2, NH2, that H2 and CHO, from that O, HO plus H2, it will form water and it will go outside. Then from the NH2, 2 hydrogen gone as H plus. Then nitrogen will get 2 negative charge. Correct? 2 negative charge. And from the CHO, oxygen will go as O minus 2, 2 minus. Then carbon will remain with 2 positive. Then carbon 2 positive and nitrogen 2 negative. Both will join to each other. Then what will happen? It will form double bond because nitrogen has 2 negative, carbon has 2 positive. Then you know that for one bond, 1 positive, 1 negative is required. Then here carbon has 2 positive, nitrogen has 2 negative. Hence it will form double bond, carbon and nitrogen double bond. Then CHO, one H was already there. Now it will be CH-double-N-OH. OH, NH2OH. One OH was there, that is that OH. Okay. Then glucose reacts with hydroxyl amine. Hydroxyl amine is NH2OH and it will form oxime. Then now what we got product, that is the oxime, NOH. Okay, that in glucose CHO was there, in that CHO O gone and N joined, make with a double bond. We got CHNOH. All things are as it is, CHOH whole 4, CH2OH. Then this is actually oxime and NH2OH OH is hydroxyl amine. Now reaction will not stop only here. Okay, that after that it adds a molecule of hydrogen cyanide, HCN. Hydrogen cyanide is HCN. This oxime will react with these, not these things. This I told you, it will give oxime. You got the oxime, NOH. Now further I am talking about glucose when it reacts with HCN, hydrogen cyanide. When glucose reacts with HCN, hydrogen cyanide, then it will form cyanohydrin. It will form cyanohydrin. Then here that again reaction will take place between OH of CHO and H of CN, HCN, that H and CHO, OH is there, then that OH and H from the CN, it will form water and it will go. Then now what will happen? That H will go as H plus, then CN will have 1 negative, and here what will happen, that this, or in a simple way you can understand the reaction, CHO plus HCN. Then here C and O double bond is there. C and O double bond is there. That will become single bond. Then O will take negative charge and carbon will become positive charge. Correct? When double bond will become single bond, the oxygen will take electron and will become negative, and carbon will be positive. Correct? Then here positive carbon and negative CN, H plus CN minus. Then CN is negative. Then that CN will join with carbon. Correct? Then now carbon joined, there's a carbon joined with CN, and carbon CN bond is formed. And now you know that oxygen has a negative charge. Then how it will be neutralized? How it will neutralize negative charge? Then from the HCN, H has gone as H plus, then that H plus carbon is positive charge, carbon is positive, oxygen is negative. Correct? Then oxygen is negative and carbon is positive. Then CN will join, CN will join to the carbon. Correct? That is right. CN will join to the carbon. Now oxygen is a negative point. Oxygen has a negative point. Then with this negative point oxygen, negative charge oxygen, now hydrogen from the HCN, that will join. Correct? Then what you will get? That now O became OH. O became OH. Then with carbon, CN has joined and O became OH. And already one H was there with carbon. CHO, that H is already there. Then only double bond, carbon oxygen double bond broken. This bond has broken and carbon became positive, oxygen became negative. Then with positive carbon, CN and negative joined and H plus from the CN joined to the O negative. It formed COH. OH bond is formed and O is attached with carbon, correct? Then now actually it formed with carbon new bond CN and COH with OH has joined and already one H was there with carbon. Then this compound now is called this cyanohydrin. Okay, means CH, from that carbon CN is attached and only from that carbon OH is there. And after that CHOH whole 4 and in the end CH2OH is there, correct? Then CHOH and all are CHOH whole 4. One side it has joined with carbon, first carbon, and other with last carbon. Then these two reaction with NH2OH and reaction with HCN, this confirms the presence of CO group, carbonyl group. How? Because reaction taken place with oxygen present on the glucose molecule. CHO, that oxygen is there. Then reaction taken place with that oxygen. That indicate that glucose has a CO group by these two reactions. Now next reaction, next evidence, fourth evidence, I am telling you that glucose gets oxidized to 6 carbon. Glucose gets oxidized to 6 carbon carboxylic acid. Means total actually is CHO, CHOH whole 4 and CH2OH is there. Then now if it is reacts with bromine water, when glucose reacts with bromine water, then every carbon will convert to this CHO, only CHO will convert to carboxylic acid. It is a CHO reaction in bromine water, that aldehyde will convert to acid. It will convert to acid. Means CHO was there, now it became COOH. This is called oxidation. Then CHO converted to COOH. Then compound will be known as gluconic acid. Gluconic acid means COOH, CHO converted to COOH, and other things are same. CHOH whole 4 and the end CH2OH. This is called gluconic acid. Then you got gluconic acid due to the oxidation. Glucose gets oxidized to 6 carbon carboxylic acid on reaction with mild oxidizing agent like bromine water. Bromine water is mild oxidizing agent. This indicates the carbonyl group is present as an aldehyde group. This conversion of aldehyde to carboxylic acid COOH, that indicates that carbonyl group is present as an aldehyde group. This conversion indicates that carbonyl group is present as an aldehyde group, because the mild oxidizing agent bromine water, due to that this converted to aldehyde converted to carboxylic acid. Then here you understood about the presence of CHO that converted to carboxylic acid. Okay, means we got an idea about aldehyde evidence that in glucose one aldehyde group is there, and also you got idea that in glucose CO group is there, and also you got idea that 6 carbons are there, correct, because it formed hexane. And in the beginning I told you that its molecular formula is C6H12O6. Now next I am telling you these things. Acetylation of glucose. What idea you will get by this reaction? Acetylation of glucose with acetic anhydride gives glucose pentaacetate. It gives glucose pentaacetate, correct? This acetylation of glucose with acetic anhydride gives glucose pentaacetate, which confirms the presence of 5 OH groups, correct? Because you know that CHOH whole 4 means 4 OH group is attached and one is in the end CH2OH. 5, total 5 OH is there. Then by acetylation it is confirmed that there are 5 OH group. Acetylation of glucose with acetic anhydride gives glucose pentaacetate, which confirms the presence of 5 OH group. Since it exists as a stable compound, 5 OH group should be attached to different carbon atoms, correct? This you got pentaacetate. Then first it will confirm that presence of 5 OH group. Since it exists as a stable compound, then a stable compound means what? 5 OH group should be attached to different carbon atoms. Reaction is again same way, easy reaction, that glucose will react with acetic anhydride, means glucose plus acetic anhydride, and acetic anhydride formula you know that CO, and that O will be not CO, O will be in the middle, one side CH3CO, other side again CH3CO, in the middle oxygen, one side CH3CO and other side also CH3CO, and from where bond will break you know, correct, that CH3CO is attached with oxygen, that C and O bond will break. CH3 is attached to CO, that O is double bond. After that carbon is attached to the oxygen, middle oxygen. Then that bond will break. Then there will be 2 parts. Then one part will be CH3CO, and that C will be positive, CH3CO, and that C will be positive, because when bond will break, oxygen will take the electron and it will become negative, correct? Then now another part became CH3CO, again one O minus, means CH3COO, CH3COO minus, it is remaining second part. Then this you remember that here this will react with this acetic anhydride will react with glucose. Then where it will react? Then here actually CHOH whole 4 was there, that will become, because OH bond will break, CHOH whole 4 is there, means 4 OH is there, then 1 by 1 means OH, when it will break OH will go as OH minus, then carbon will become positive. Correct? OH bond, when it will go as OH minus. One by one, understand, one OH gone. Then carbon got one positive. Then negative oxygen will join there. Means CH3 COO, one minus. And second part will join here with carbon. Then what you will get? You will get CH3 COO. CH3 COO, one minus was there, that joined with carbon. Then there are 4 OH group. 4 OH group is attached with 4 carbon. Then everywhere they will make this type of bond. Means carbon will join with CH3 COO. Then you can write that is just like a CHOH whole 4. Now you can write CHO. CH3 COO you can write 4 times. Or bond, with bond you can tell CH. With this COO CH3 has joined. That 4 times you have to write same things. CHO CO CH3 whole 4. Correct? And in the end that will be also same structure, because OH is also there. OH is also there. Wherever OH is there, then there same bond. Same bond means CH3 COO will join. Correct? Then here you will, in the end you will get CH2O CO CH3. CH2O, because O has joined with carbon. CH2O CO CH3. Then total 5 acetate ion joined. 5 acetate ion joined with in the place of 5 OH minus. Correct? From each carbon OH minus gone. Then this OH, 5 OH minus, 5 OH, where it gone? OH is negative charge, then where it will go? Then it will go to the CH3 CO, that carbon was positive, first part of acetate cannot write. CH3 CO, double bond, and that carbon was having positive charge. CH3C, from that C, oxygen is joined with double bond, and that carbon is positive. From this positive carbon, OH minus will join. Hence you will get 5 molecules. Means you will get here now CH3 COOH. CH3 COOH. Acetic acid, 5 molecules you will get. Okay. Then this reaction, acetylation reaction, confirms the presence of 5 OH group. Now next evidence I am talking about, that on oxidation with nitric acid, glucose as well as gluconic acid both yields a dicarboxylic acid, that is called as saccharic acid. This indicates the presence of a primary alcohol in the glucose. Okay, primary alcoholic group in glucose. This is the, I can say, proof that presence of a primary alcoholic group in glucose. OH group is attached. Again I am telling you, on oxidation with nitric acid, glucose as well as gluconic acid, any either glucose or gluconic acid, whatever be. Okay, gluconic acid, you know that in the place of CHO, that will be COOH, and whatever be any one or both yields a dicarboxylic acid. It will give dicarboxylic acid. Okay, on oxidation with nitric acid. And this dicarboxylic acid is also called saccharic acid, because now you got that CHO CHOH whole 4 CH2OH. This is the glucose. And here OH is in the first carbon and OH is in the last carbon also. CHOH whole 4 in the middle. That will remain as it is. But first carbon, because it is nitric acid, is oxidizing agent. Then CHO will convert to COOH. First change. And another change also CH2OH. That will also convert to COOH. In first carbon, last carbon, that became carboxylic acid. Correct? First carbon became COOH, last carbon became COOH. But there CH2OH was there. And the first carbon, CHO was there. Correct? Then CHO that converted to one oxygen came. That's why it became COOH. And here last carbon, that H2 from the CH2OH and oxygen from oxidizing agent, it formed H2O and it went. And in the place of 2 H2, 1 oxygen joined. Correct? 2 hydrogen is equivalent to 1 oxygen, because oxygen has 2 negative. Then now last carbon also 1 oxygen joined and 2 hydrogen gone. Then you got COOH. This is called dicarboxylic acid, and another name is citric acid. And again, if you will consider gluconic acid, then in gluconic acid already one carboxylic group is there. Then last is the last carbon CH2OH is there. Then on oxidation, last carbon will convert to last carbon, that CH2OH. Now it will convert to COOH. Means in both cases, either from gluconic acid you take gluconic acid, or you take glucose. Finally you will get citric acid, means dicarboxylic acid. This indicates presence of a primary alcoholic group, OH group, primary alcoholic group in glucose. Now this I have told 6 evidence. Okay. Now arrangement you can see, means now OH is there. OH is there, 4 OH is in the middle 4 with 4 carbon, 4 OH is attached, and other side hydrogen is there. You have to make tetravalency of carbon, means 4 valency of carbon you have to maintain. Then 1 carbon is attached with upside carbon, and one carbon is attached with first carbon. Okay, second I am talking about. Second is attached with first, and second is attached with the third carbon also. Then 2 valency over, and left side 1 H, it is joined with H, and right side with OH. Same thing is with all carbon, all middle 4 carbon. In the first carbon it is the CHO, COO and H, and last is the carbon CH2OH. Then now question arises that what is the actually arrangement, spatial arrangement? The exact spatial arrangement of different OH group was given by Fisker, scientist. The exact spatial arrangement of where actually OH will be there. Now in general you told 4 OH group is there, but whether it is right side or left side. If left side, then how many OH are in the left side? If right side, then how many OH are in the right side? Means left side also OH is there, right side also OH is there. But here I want to tell you, when left side OH is there, then in that carbon other side hydrogen will be there. Just correct, a reverse way. If left side OH, then the right side H. If right side OH, then left side H, because carbon has to has to maintain tetravalency. Then now actually how many OH will be left side and right side? That is actually was given by Fisker, scientist, chemist, Fischer, Fisker, after studying many other properties. Its configuration is correctly represented as I will actually three structure is there. Three structure is there means spatial arrangement of different OH group. You can write in three ways. Then first I am telling you, and actually this first structure only is the correctly representation of glucose. Then here that first carbon, that is the okay, CHO is there. Last carbon CH2OH is there. Forget this. Now think for the 4OH. Then now first and second carbon OH, second and third carbon. First carbon, that is the CHO. Forget. Second and third carbon OH is in opposite way. Second carbon OH in the right side, then third carbon is on the left side. Correct? And where OH is there, its opposite side H will be there. Correct? Means second carbon, right side OH is there, then left side H is there. And third carbon, left side OH is there, then right side H is there. Correct? Then here you have seen second and third carbon, that OH is second carbon, OH is right side, and third carbon OH is the left side. OH only you consider. Then after that what is remaining, that will be the H, opposite side H. Then now second and third carbon you have understood. And next fourth and fifth carbon OH are in the right side. OH is in the right side. Carbon number 4 and carbon number 5. Then left side H and H will be there. Then this is the correct way of correct representation of glucose. CH2, last carbon you are writing CH2OH. That is actually right direction only. Okay, in right direction. And this first CHO, actually that is the OH group is not there. Last carbon actually CH2OH, that is the OH. But first carbon, it is aldehyde group, CHO, not the carboxyl, this OH group. Okay, this is not a OH group, this is a CHO group. Correct? Then this is the correct representation of this glucose. But what are the other two representation? And second representation, just you can write all things will be as it is, only CHO. In the place of CHO you write COOH. Simple. Gluconic acid. Gluconic acid, all things are same. COOH. In the place of CHO you write complete. In the place of CHO, that will become COOH. Gluconic acid. In this way also it is represented. This is the second representation of glucose. Okay. So it is gluconic acid. Then OH arrangement I am talking about, exact spatial arrangement of different OH groups. Okay, that was given by Fisker after studying many other properties. Then now third representation, that is the saccharic acid. In saccharic acid, again there will be two COOH, one COOH first carbon, last carbon COOH. Okay, and in the middle OH, again it will be the same way. In all three structure, OH position will be the same. Then first structure, in terms of aldehyde, it was in the first carbon was C in the form of CHO, last carbon was CH2OH. This is the first representation. Second, all thing was same. That first CHO now it became COOH, means gluconic acid. In that also OH group is as it is. Position of OH group is same like first representation. Third, again in the middle all things are same, only last carbon again it is became CH2OH became COOH. Okay, this is called saccharic acid. Glucose is correctly named as D-glucose, D plus glucose. You remember, glucose is correctly named as D, and in bracket you can write 1 plus D, that is called D-glucose. Then plus and minus sign I will tell you that, but here glucose is correctly named as D-glucose. D in bracket you write plus and then glucose, D-glucose. D before the name of glucose represents the configuration, whereas plus represents dextrorotatory nature of molecule. Actually, I want to tell you two things you have to understand. Always a student will get confused. Here positive and negative sign first understand meaning. If plus is there, then plus means it will rotate the plane polarized light to the right direction. That is the dextrorotatory. That is indicated by plus, because if solution of glucose you will take and plane polarized light will be passed through the solution, then it will rotate the plane polarized light to the right direction. Then that glucose is called plus glucose. Okay. And if it is rotating the light to the minus to the left direction, then it is called minus glucose, minus sign. Okay, minus means that is the left direction. If glucose is rotating to the left, it is rotating the plane of polarized light to the left, then it is given negative sign. Now come to the letter D. Then here you have to understand the meaning of D or L. D or L, capital D and capital L. Meaning you should understand. This I told you positive and negative sign. Positive sign means dextrorotatory, right direction. And negative sign means LAVO, L-A-E-V-O, LAVO, left. Okay, left direction. But D and L, what do you mean? And for that you should understand that D, the letter D or L before the name of any compounds, the letters D or L, capital D, before the name of any compound indicates the relative configuration of a particular stereoisomer. One standard isomer is there. That is called a stereoisomer. Stereo what you are using because it tells about the direction, particular direction. Okay. Then a stereoisomer, one isomer is there, a stereoisomer, not ordinary. Okay, which will this stereoisomer means optical distance activity, then only that way isomers are there. That is called a stereoisomer, because one rotate to the positive, other rotate to the negative. That you know. Then here D and L meaning you understand. One can say a stereoisomer you are taking as a standard. The letter D or L before the name of any compounds indicate the relative configuration of a particular stereoisomer. This refers to their relation with particular isomer of glyceraldehyde. Glyceraldehyde is a stereoisomer. Then in respect of that, you are talking D and L. Okay. This D and L refers to their relation with a particular isomer of glyceraldehyde. Glyceraldehyde exists in the isomers. Okay, isomer meaning you know, chemical formula same, structural formula different. Then glyceraldehyde formula you have to write, correct? Then glyceraldehyde formula how will you write? Then that what is the glucose? I told you CHO is first carbon is CHO. First carbon is in the form of CHO. Last is CH2OH. But here in the middle one carbon is there and left side H is there, right side OH is there. This is actually glyceraldehyde. Glyceraldehyde. Because it is aldehyde, CHO is there. After that in the middle between the CHO and CH2OH only one carbon is there. Only one carbon is there. One side means left side H is there, right side OH is there. Then this is actually glyceraldehyde. Here you have to just one thing I am pointing out important things. All this middle carbon has joined with all different group. Middle carbon, one side H, other side OH, upside CHO and down CH2OH. Correct? No group is same. All fours are different. Okay. Then this actually is a positive. This is the dextrorotatory positive, and other that now I told you left side H, right side OH. Now in second structure you just reverse it. Then left side OH, right side H, and CHO and CH2OH is the same position. Okay. First carbon CHO we are writing and CH2OH is same in both. Only OH position has changed. In the plus means dextrorotatory, OH is in the right and H is left. Now it became in second structure it reversed. OH is left, H is right. Then this is the minus glyceraldehyde. This you remember. Minus glyceraldehyde. Plus glyceraldehyde minus glyceraldehyde. Then position of OH group is important here, because only on the position you will use the word D and L before the name of glucose. All those compounds, listen carefully, very conceptual. All those compounds which can be chemically correlated to plus isomer of glyceraldehyde are said to have D configuration. Capital D you can write for the positive. All those compounds which can be chemically correlated to the plus isomer of glyceraldehyde first structure are said to have D configuration, whereas those which can be correlated to negative isomer of glyceraldehyde means second structures are said to have L configuration. Means D and L is telling about configuration. Then in the first structure, OH was in the right, and in second structure means negative, it was left. Then you can compare. You can compare with two structure. If OH is in the plus isomer, plus glyceraldehyde, means OH is in the right, then only you can use the word D. If it is the OH is in the left side, then you can use the word L, and that will be also minus. For assigning the configuration of monosaccharides, it is the lowest asymmetric carbon atom which is compared. Here again important point, because glucose 6 carbons are there. 6 carbon will be there, but here if you want to tell whether you should write D or L, then for that you see means only 2 carbon you consider, last 2 carbon you have to think. Okay, lowest asymmetric carbon you have to think. For assigning the configuration of monosaccharides, it is the lowest asymmetric carbon atom which is compared. As for example, as in plus glucose, OH group, last carbon you can see, last carbon means asymmetric carbon, CH2OH is the last, then that it does you consider middle carbon. Only first 3 carbon you consider from the last, and then again above this, and again above this. Then you think like that only glyceraldehyde structure, that is the asymmetric, means all 4 groups are different. Then last carbon, lowest you can tell, lowest asymmetric carbon atom. Okay, you have to compare. Okay, means the last 3, or just like glyceraldehyde, you keep in mind. Then there only 3 carbon is involved, CHO, that carbon, in the middle carbon, and last carbon CH2OH. Then only this structure you have to compare with glucose, any other glucose. Correct? Whether it will be D or L. Then example I am telling you for glucose. Suppose you are considering glucose, whether it will be D or L, then glucose OH on the lowest asymmetric carbon, asymmetric. The OH on the lowest asymmetric carbon is on the right side in glucose. In glucose structure, first structure, I told you 3 structure at that time. Then first structure, correct? That asymmetric carbon you have to think, means 4 different group. Then with the middle 4 different group means what in glucose? Last is CH2OH, and left side H, right side OH. And what are the remaining CHO? Just don't count CHO. Correct? In the middle 4 CHOH is there, that you don't count. You consider all as a separate group. Then obviously that will be different. Only middle carbon, second carbon H and OH you consider, and then you think that fourth group is CHO, like that way you think. Or you can think that CH2O is the last, and middle carbon H is there, right side OH is there. Then one more bond you have to make. Then you consider that all what is the remaining in glucose, that you consider as a one group. Correct? Remaining part of the glucose you consider as a separate group. Then you will think that you consider only one group. then you think that now OH is in the right. In glucose, you compare with glyceraldehyde, then both are the same, right side only. In glucose means fifth carbon you can tell, sixth carbon is CH2H, then fifth carbon, right side OH is there. And here in glyceraldehyde also, it is in right direction. That's why it is given, it is like a plus, it is matching with plus. Then it is called D. Okay. Then it is called D, right side, which is compared to the plus glyceraldehyde. So it is assigned as a D configuration. D and L is telling about configuration, not the this things direction. Direction is telling positive and negative, but positive means dextrorotatory, you remember, and negative means laboratory. Okay, that is plus minus means dextro and labo, but D and capital D and capital L is telling about the configuration. Question is asked. Okay, then for this comparison, the structure is written in a way that most oxidized carbon is at the top. Oxidized carbon is at the top. Okay, then here D-glucose. Now glucose structure you are knowing. Then main things what you have considered, that you have written complete structure of the glucose. Then this last two carbon only you have to consider. Then now we will compare that in glucose, in plus glucose or simply glucose, that last two carbon of glucose and last two carbon of glyceraldehyde, both are same. Glyceraldehyde, last two carbon, OH is in the direction, same direction as glucose. If it is like that, that in glucose OH position are the same as glyceraldehyde, last two carbon, then it means that glucose is D, and that is the plus. You can write D, and in bracket you can write plus glucose. Okay, then this I have discussed the structure of glucose. Question is asked, because many reaction I discussed. Then how means they will ask how will you understand the structure. Okay, then this means evidence. You have to remember evidence that 5 OH is there. How will you tell that glucose has 5 OH? How will you think that how will you prove that glucose has CO group? How will you prove that glucose has CHO structure? Correct? How will you tell that glucose has 6 carbon? Correct? Then all things I have discussed. And now I am stopping only here. Next class I will discuss cyclic structure of glucose. Cyclic structure. Okay, this what I have discussed. This is the Fisker structure. FISCHER. Okay, this I have discussed. Now cyclic structure means the cycle form. One is in the open structure. What I discussed, open structure. Now next class I will discuss cyclic structure of glucose. Okay, thank you.